Here we go, algebra maniacs. All right, so we're looking at example number 4 for higher degree equations. Once again, this would be considered a higher degree equation because that variable x is to the third power. Anything higher than second power we'll put into this particular category. Notice again, there's no simplification in terms of, well, let's get that up here. There's no simplification issues in terms of clearing fractions, distributing, combining like terms. So we move forward. We also notice that the variable x is in only one term. And again, I would always think this is the best case scenario. We don't have any control over the equation. We just go with the flow. But if you're lucky enough, in my opinion, to have the variable in one term, that's the best of all scenarios. All right, so anyway, the operation that's furthest from x would be the addition of 17. So the first step would be to subtract that 17 over to the other side. Once again, addition and subtraction are called inverse operations. So we now have 5x cubed equals negative 17. Back to the order of operations. In reference to x, wouldn't you do the exponent before you do the multiply by 5? So again, that multiply would be the next one up the ladder here. And you get rid of that multiply by 5 with divide by 5. So we now have x to the third power equals negative 3.4, I believe that is. I hope I'm correct on that. All right. Yes. So, now what? I always say here you stop and you think about, could x be positive, could x be negative? All right. So when you look at this, you would hopefully say to yourself, if I were to plug a positive number in for x and raise it to the third power, aren't positive numbers raised to any power positive? And this is a negative number sitting over here. So there's no way that sticking a positive number in there and raising it to the third power is going to produce a negative number. So goodbye, plus. You're gone. See, this is different. All 4 of these scenarios in examples 1, 2, 3, and 4 have different behaviors. And I'm trying to illustrate each of them. All right, what about a negative number? A negative number raised to the third power. Well, guess what? That third power is odd. And if there's anybody who knows anything about odd, you're looking at him here, Mr. Cinnamon Bread. All right, but anyway, negative numbers raised to odd powers come out negative. Yay, negative, ding, ding, ding. You can stay in the party. So we're only going to get one negative real solution here. All right, so now, just like we've seen on previous examples, how do you get rid of a third power? You get rid of a third root. Or you introduce a third root, pardon me. All right, so again, that third root gets rid of that third power and changes this into x. And then, how in the world am I going to get a third root in my calculator? That's not the same thing as that square root key that's probably very obvious to you. So again, my strategy has become over the years to say, you know what, that number under there has a first power on it. So I'm going to call this negative 3.4 in parentheses to the 1 over 3 power. All right, and so if we put that in the calculator, being very careful with our parentheses, and again, I'm sorry that you can't see the calculator in my hand, but that's just the way it goes. If we put negative 3.4 in parentheses and raise it to the parentheses 1 divided by 3, we will get, the calculator spits out negative 1, that marker's not too good, negative 1.50 when you round it to 2 places. And I will also note here, the calculator did, as we predicted, spit out a negative number, but we don't provide the corresponding positive. So, that would be scenario number 4 in terms of the behavior of roots. Let's go to that now. What happened here? We just introduced an odd root, a third root, to a negative number. When you put an odd root on top of or apply it to a negative number, radicand, fancy word for number under the radical, when you put an odd root like a third root on top of a negative number, you're only going to get one negative real solution, as we see. All right, so examples 1, 2, 3, and 4 showed these 4 different scenarios, and so when you run into those scenarios yourselves on your homework, keep that in mind and be mindful of these different behaviors. All right, so we'll be ready to move on to example number 5 here very soon. Thank you. Wasn't that radical? I got the power.